In this video, I'm going to talk about Multiple VLAN Registration Protocol. MVRP is a protocol that lets switches advertise VLANs across trunk links. The goal is to do less manual VLAN work between switches. What it essentially does is it sends MVRP PDUs when VLANs change, and neighbor switches process those PDUs and update their VLAN registrations. But it is rarely used in production. Automatic layer 2 features like MVRP can be risky because they are hard to control, audit, and troubleshoot. Therefore, it is better to use explicit VLAN configuration. Let's start configuring MVRP. In this topology, switch 1 will be the source of the VLANs and switch 2 will learn the VLANs from switch 1. First, we will create the VLANs on switch 1. We will go configure, set VLANs, v10, VLAN ID 10, we'll use v20 for VLAN 20 and v30 for VLAN 30. Now we will configure the two access ports. If we don't configure the access ports, the VLANs don't become active and nothing gets propagated to the other switch. XE000 will be the VLAN 10 access port and 01 will be the VLAN 20 access port. We'll go set interfaces, XE000.0 family Ethernet switching, VLAN members v10, and we'll use v20 for 001. Next, we will configure the uplink from switch 1 to switch 2. The uplink is going to be the XE002 interface, and we will make it a trunk, and we will allow the VLANs we want the other switch to learn. We'll go set interfaces, XE002.0 family Ethernet switching, interface mode trunk, then VLAN members v10, v20, and v30. We will also enable RSTP on the participating interfaces. MVRP works with the switching control plane state, so we want the interfaces to be in a good layer 2 state. We don't want loops or anything like that, so we'll enable RSTP. We'll go set protocols, RSTP, interfaces, XE000, XE0001, and 2. At this point, we are done with switch 1. It has the VLANs, access ports, and trunk to switch 2. We'll commit this and quit. Now we will move on to switch 2. Switch 2 is the site that will learn the VLAN information, so we need to configure the trunks first. We'll go configure, set interfaces, XE000, 2.0 family Ethernet switching, interface mode trunk. Then we will enable RSTP, set protocols, RSTP interface, XE002. Now we will enable MVRP on the trunk between switch 1 and switch 2. If we try to commit like this, it's not going to allow us because we have not configured any VLANs on the trunk interface. We'll go set protocols, MVRP interface, XE002. It's that simple. We'll commit this and quit. Now we will move on to switch 1. Do the same thing there. We'll go configure, set protocols, MVRP interfaces, XE002. Commit this as well. Now switch 1 can advertise VLANs and switch 2 can register what it receives dynamically. If we move on to switch 2, we can verify what is actually happening. If we say show MVRP, here we can see that MVRP is enabled on XE002. We can also see the timers. The join timer controls how quickly join messages are sent. The leave timer controls how long the switch waits before removing VLAN information. The leave all timer controls when the switch asks for a full refresh of registrations. If we say show MVRP dynamic VLAN memberships, it shows which VLAN switch 2 learned through MVRP. At this point, we expect to see VLAN 10 and VLAN 20. We don't see VLAN 30 yet because it's not active on any access interface on the other switch. There is another useful command, show MVRP statistics. Here we can see the protocol counters. This is useful when troubleshooting. The main thing we care about is whether switch 2 is receiving MVRP PDUs without errors. If the counters are moving, that means the control plane is working. Now we will test the full register and withdraw cycle using VLAN 30. First, we will make VLAN 30 appear on switch 2. then remove the activity on switch 1 and watch switch 2 withdraw it. We'll go on to the switch 1, then we will set VLAN 30 as an access port, set interfaces XE004.0 family Ethernet switching, VLAN members V30. We'll commit this, and after the timer is over on switch 2, we should see VLAN 30 after typing show MVRP dynamic VLAN memberships. Next, we will remove the VLAN 30 access port from switch 1 and watch switch 2 withdraw the VLAN 30 from its database. We'll go delete interfaces XU004. We'll commit this. Now we will check switch 2 again. VLAN 30 will disappear if we say show MVRP dynamic VLAN memberships. In the end, MVRP tries to reduce manual VLAN work between switches, but while doing that, it can create more problems than necessary. Static trunks and automation are easier to control. MVRP is great for learning, but in production it should be used carefully if it's going to be used at all. If VLAN 30 appears somewhere, we want that to be because it's explicitly configured. So this is the full lab. We created VLANs on switch 1, enabled MVRP on the trunk, verified that switch 2 learned the VLANs, then used VLAN 30 to see both registration and withdrawal process. Thanks for listening. See you next time.